Okay, we're going to look at section 32, which is going to look at statistics and standard deviation and the interquartile range and the semi-interquartile range. Now, the standard deviation is a statistical measure of spread. So this question, we're going to be asked to calculate the mean standard deviation. The context of the question is a machine is used to put drawing pins into boxes. 8 boxes are then sampled and we count how many pins are in each box. So the results there are 102, first box, then 102 again, 101, 98, 99, 101, 103 and 102. Okay, the first thing that I need to do is calculate the mean. So the mean is given by x bar, and the mean, remember, is when you count up all the numbers, get a total and divide by the amount of numbers in the list, which is 1, 2, 3, 4, 5, 6, 7, 8. So we're going to total that up and divide by 8. So the mean then is equal to 101. I'm now going to calculate the standard deviation. So I'll go to the formula sheet and pick out the standard deviation formula, which is standard deviation equals the square root of sigma x minus x bar all squared divided by n minus 1. N is the sample size, so that's the number of pieces of data in the sample. That's n, so n minus 1 is that value, take away 1. I then set up my table. So the first column, x, is all the numbers in the sample, 102 down to 102 down the bottom. I then do a column which is x minus x bar. So that means that I take the number in the first column and subtract x bar. So remember that x bar is the mean, 101. So 102 minus 101 is 1. 102 minus 101, 1 again. 101 minus 101 is 0. 98 take away 101 is minus 3. 99 take away 101 is minus 2. 101 take away 101 is 0. 103 take away 101 is 2. And 102 take away 101 is 1. We then square all those values. Form a third column, x minus x bar all squared. 1 squared is 1, 1 squared is 1, 0 squared is 0, minus 3 squared, that will give me positive 9, minus 2 squared will give me 4, 0 squared is 0, 2 squared is 4, and 1 squared is 1. I then total my third column, and that gives me sigma. Sigma just means total, so total of x minus x bar all squared. So that's 1, 2, 11, 15, 19. I then use my formula, which is the standard deviation is the square root of sigma x minus x bar all squared divided by the sample size minus 1. So that is the square root of, well, I just lift that straight from here, of 19 divided by the sample size, take away 1. Sample size is the amount of numbers in the sample, which is 8. Take away 1, that's 7. So it's the square root of 19 over 7. And the standard deviation is to 2 decimal places, 1.65. Part B of the question then says that another sample of 8 boxes is analysed from a second machine that does the same job, and the mean this time is found to be 103 and the standard deviation at 2.1. So what we're looking to do is make 2 valid comparisons. So the first comparison that we're going to make is a comparison of the means, and then we'll make a comparison of the standard deviations. Okay, so the mean is a measure of the typical value. Now, what we need to include in the question to make sure that we pick up the marks is the context of the question, which is machines that sort pins into boxes. We did a numerical comparison, and if we're talking about the mean, we comment on the average. So what we could say there is, on average, the second machine So that's the context of the question. Sorts more pins into boxes. So we need to say on average because it is just a measure of the average. Since 103 is greater than 101. We're now going to comment on the standard deviation. The standard deviation is a measure of spread, so the second comment on the standard deviation, which is a measure of spread, will include the context of the question, a numerical comparison, and a comment on the spread. So we can see that the standard deviation for the second machine is greater than the standard deviation for the first machine. Therefore, what we can say is there is more spread in terms of the number of pins in the boxes with machine B since 2.1 is greater than 1.65. So again, we've got the context of the question, which is pins and boxes, a numerical comparison, and talking about the spread.